Hello and welcome my dear students. So in this lecture series I am going to solve some of the interesting and challenging numerical problem from the physics book Pathfinder. So let us start with the situation over here. So in this situation the small ball P is suspended from a fixed nail point O. So O is the point about which the ball is being released. So this is the ball. Let us see this is the ball part. Okay. So ball is being released. Now there is another nail P at a distance of R. So there is another nail P. Now once the ball is coming down, so it will hit the nail and ultimately it will perform a vertical circular motion about this nail point. So this is the particle ball. Now what is the length of the radius, or can I say the length is basically now L minus R. Now it will perform a circle of L minus R. It will perform a circle of L minus R about this nail point. Now, you are asked to calculate the range of values of small r. Small r is the position where the peg is being fixed, so that the ball makes a complete circular turn about the nail. Okay. So, in order to make the complete circular turn, I know that the velocity should be equal to root of 5gr at the bottommost position. So here, let us say the particle is getting a velocity of v. Okay, v. So if I say is the v part, so descending the ball from point A to B. Let us initially the ball is at point A and finally the ball comes to this point. So because of this downward movement, so potential energy is being dropped. So what is the potential energy dropped by the ball? Can I say that is equals to, it is equals to L minus R plus R cos theta number. L minus R plus R cos theta, this one is R cos theta. Okay. So ultimately drop in potential energy, I can write that mg into L minus R plus R cos theta. There is a drop in potential energy. That should be equal to gain in kinetic energy. Now what is gain in kinetic energy? That is equal to simply half mv square. Why? Because at this point the particle is released. So here it is given that the particle is released. So here the velocity is 0. So only thing gain is the kinetic energy is equals to half mv square. Okay. So from that what I am getting, that v number should be equals to root of 2g into L minus R plus R cos theta. Now this is the velocity at the bottommost position. So in order to make the particle to complete the vertical circle, so that must be greater or equals to root of 5gr. This is the condition for the vertical circle. Now what is R? R is the radius of the vertical circle. Now what is that number? That is equals to L minus R. So can I write that should be equals to under root of 5g into L minus R. Okay. So if I simplify this number, so ultimately I can get the value of R number. So square both sides. So ultimately what I am getting, that 2g into L minus R plus R cos theta, that should be greater than equals to 5g into L minus R. Okay. So simplify this and ultimately on simplification, I will get the number of R is greater than or equals to 3L divided by 2 cos theta plus 3. 2 cos theta plus 3. Please check it and write in the comment box so that I will be getting the same answer or not. 2 cos theta plus 3. Okay. So 2 cos theta plus 3 divided by 3L. So that is the value of R. So for this R only, the particle or the ball will complete the vertical circle. So hope you understand this. Thanks for watching the video. If you like it, please subscribe my channel.